you've ever heard of the word inference?
No, I never heard.
Have you heard it in first grade? Nobody?
No.
So when you make an inference, sometimes when we read a book, the author doesn't tell us everything. Sometimes we need to think about it. We make an inference or a guess about what's happening or what's going to happen next or what would happen.
Don't mess with
So,
the pencils. Okay.
We use what we already know and then what we read from the text to make an inference. So we're going to practice doing that today. So before we read, we're going to go over our vocabulary. Because these are some words that we might see while we read. So I'm going to say the word, then you will say the word, then we'll talk about it.
Okay.
Tasty.
Tasty.
What does it mean when something is tasty? So raise your hand. Julian?
It means that when you're eating something, it tastes so good that you want to eat
So when something is tasty, it's good. Would we say that our socks are tasty?
No.
Okay. The next one is amount.
Amount.
So look at the picture.
Amount.
What do you think amount means? Jeremiah? The same amount? Emma, what do you think? Amount. Look at the picture. Right, so it shows how much of something there is. The amount of something. Material. Thank you, Nina. Let's try again. Material. What is material? So we don't need to make the noise. I see your hand. Picture. Joshua, what is material?
Materials are things that you use to build stuff.
Okay, so it's what something's made from. Good job, material. Space.
Space.
What does it mean when you have space?
Oh, that's easy.
Alan?
So you have some space to move.
Right, so you have some space to move. So what does that mean? Is it crowded around you?
No.
No.
That means that you have space.
Right.
Oh,
Like
yeah.
there's empty room around you, right?
Yeah, there's empty room around. Oh.
The next word is example. Oh, thank you, Nita. Try again. Example. What does it mean to give an example? Juan?
Like if I have one banana and 10,000 apples, and the banana is 50.
Okay, who can help us out a little bit? Ellie?
You have a banana and you kind of describe it, like say it's yellow or has some green on the back.
Okay, what if I said a banana is an example of a type of fruit?
Oh,
Right? So an example is like a part of something bigger. So you know when we do our sentences, we do examples before I give you your own paper?
Yeah.
Right, like we do a part and then you do the whole thing by yourself, right?
Yeah. It's an example how to do it, and when you figure it out, we do like 1 and 2.
Right.
Oh.
Easily.
Easily.
Oh, let's try again.
Easily.
If you can do something easily, what does that mean? For example, we're in 2nd grade, so we can easily count to 3.
1, 2, 3.
Right?
1, 2,
So what does that mean, Matthew?
It means if we do something that's pretty easy.
We can do so. Is it hard for us?
No.
Their next word is forms. So you should not have any pencils. So look at the picture of all these do you notice? What do you think forms mean?
Oh!
Dylan, if something has many forms, what do you think that means? Table 1.
Many white stuff.
Many stuff. What do you notice about the pasta? Are they all the same? What's different about them?
They're all different.
All different
Forms.
Right, they're all different forms. So when something's a different form, it's a different shape, or it has a different way of being. But is all of this still pasta?
Yeah. The
It's
chunky
just-
one is better.
It's just in a different
It
form.
might not taste the same, but it's still pasta.
Right, still pasta. And our last word is planet. So say it with me.
I
Is a planet.
on my phone.
You have a planet on your phone?
Yeah, like the whole entire Earth and half of the Earth.
Oh.
Like in space. It's like my dad.
So I'm going to show the picture really quick. England, what do you think a planet is? So England's talking, that means no one else should be. So planets are like in space, right? And there's something large, and they move around a star. Joshua, what else?
A planet is very important because a lot of people live in there. Because if Earth wasn't there, then we wouldn't even exist.
Is Earth the only planet?
No.
We have more than planet Earth. Okay, so you are going to grab your book, your orange book.
Which page should we go to?
And you are going to go to page 100 and 122. So when we go and do turn talk, I need you to go, okay? So just try your best, okay? You're going to have to look at the Okay. So we are going to read. We are going to read many kinds of matter. This is an informational text. What does that mean? Raise your hand if you remember. Informational text. Alan.
What?
Emily. It's going to tell us something. It's going to give us facts or details or information. Is this going to be true information?
Yeah.
Or is it going to be not true? Is it going to be made up? So thumbs up if you think the information is true. And thumbs down if you think the information we are going to read is made up. Meaning it's pretend. So I should see everyone's thumb in the air. Joshua, thumbs up or thumbs down? Do you think the information we are going to read is true or pretend?
I think it's both.
You think it's both, Bryce?
Yes.
Why do you think it's both?
Because, like, documents and
But this is informational.
So
I'm talking about just what we're reading. Is this going to be true information or false information? So this is nonfiction. When a text is nonfiction, what does that mean?
Not me, that's true.
It's true, right? Okay, so while we read, we are going to practice making inferences. So many kinds of matter. Matter is everywhere. Anything that has mass and volume. Mass is the amount of material in an object. Volume is the amount of space an object takes up. Trees, lakes, and people are matter. All have mass and volume. Look at our picture.
Ooh.
So, the little circle, the caption tells us that trees, lakes, and people are matter. But what about the boat? Do you think that's made up of matter?
Yes.
Why do you think that, Nee? Okay, what else? Matthew?
Because everything has matter inside.
Right, is it taking up space?
No.
Yes.
Yes. But does the author tell us boat, trees, lakes? Does he list the boat? No, but can we make an inference that the boat is made up of matter?
Yes.
Yes. So 125. There are 3 kinds of matter: solids, liquids, and gases. Look at the picture. Do you see all 3 types?
Yes.
Is that picture a good picture to use that shows you a solid, a liquid, and a gas?
Yes.
126. Solids.
Turn the page.
Books, rocks, and toys are solids. Solid matter holds its own shape. Solids do not take the shape of their own container. Marbles fill a jar, but the marbles are still round. Books are one example of a solid. The shape of solids do not change when you put them in a container. What would happen if you put those marbles in a bowl?
They'll still face.
Are they still going to be round?
Yes.
Yes. Solids are not easy to compress. So this is a word we need to listen for because we're going to hear it throughout the book. So heads up.
Compress.
Compress means to squeeze something into a tight space. So show me with your hand. Squeeze your hand. You're squeezing something into a tight space.
Yeah, my arms are turning.
Bottles and cans are solids. It's not easy to squeeze them in this recycling bin. So, we're going to make an inference. Why is this boy carrying the recycling bin? So, stand up. You are going to make your first prediction. So I'm going to give you 1 minute. I want you to walk around the room and tell a partner, I infer that the boy is carrying this recycling bin because, or say, my guess is, I think, or I predict. Okay? So I'm going to have to stand up. So why is the boy carrying the recycling bin? Go. So why is he carrying it in the bin?
What do you think of this? Come here. What are you doing? I got that before.
Okay. So in 5, 4, you back, you see by 3, 2, 1. What are some inferences that you made with your partner? Maybe you heard an inference.
I didn't have a partner.
Oh,
I had a partner.
so we need to work on
and
it.
he missed it.
Matthew, what's an inference you made?
My partner or
Either one, you or your partner.
I made an inference that his mom told him to cycle for chores.
His mom told him to recycle for chores. That's why he's carrying the bin. Okay. Kennedy. He's helping the world. Okay, so look at the bin. Is it full?
Yes.
So you're looking at the picture. You're not flipping your book. Would he carry all of those materials in his hands?
No.
No. What would happen?
It will fall.
It would all fall. So that's what I infer. I predict he's using this bin to carry everything because he can't carry it with his hands because it'll all fall. Yes, Joshua.
He's helping the world to be a better place so the roads and the grass in your house won't be all buried.
Right. So our books are down. Okay, page 128. So flip the page.
They're going to use the bottles again.
Solids do not flow. Solid candies don't spread. Solid candies don't spread across ice cream in the way hot fudge sauce does. Candy sprinkles are solids. They do not flow over ice cream. Is the hot fudge sauce, is that a solid? Yes.
The hot fudge.
The hot fudge sauce, is that a solid?
No.
No. Why? How do we know that's not a solid?
Because it drips down the ice cream.
It's dripping.
Yeah.
Are the sprinkles dripping down? No.
They're staying in the same place.
Right. Liquids. Oil, syrup, and water are liquids. Liquid matter does not hold its own shape. Liquids take the shape of their container. Water inside a swimming pool takes on the shape of a pool. Oil is one example of a liquid. Water in the square pool takes on a square shape. What would happen? I want you to make an inference. So we're not turning the page yet. What would happen if we poured this water from the square pool into a round pool? Turn and tell your partner. What do you think would happen? So what do you think would happen? If we put the water from the square pool into a round pool, what would happen to the water? Okay, 5, 4, 3, 2, 1. Jeremiah, what do you think would happen if we poured the water from the square pool into a circle pool? What inference can you make? What do you predict would happen to the water? It would take the shape of the circle pool, right? Would it stay a square?
No.
No. What about the oil?
Or then just what? It will not be half of the water, but you will not be there.
What do you predict would happen if you pour oil? So who has seen a bottle of oil, like cooking oil? What happens when mom or dad or anyone that's cooking?
Fire.
Okay, pours the oil. Oh, okay, so when I'm interrupting, pours the oil into a pan. Does it stay the same shape it was in the bottle?
No.
No, what happens to it?
It makes the shape of the pan.
Right, it makes the shape of the pan.
Well, kind of. And it's like still.
Okay, turn the page. Liquids are not easy to compress. Milk is a liquid. You couldn't fit the milk into the jug. You couldn't fit the milk in the jug into the little carton. Liquids flow. Liquid syrup spreads across pancakes. So I'm going to give you 45 seconds. I want you to tell me.
Why does it sound like that?
It's just beeping. I want you to make an inference. What do you infer? What do you guess or predict would happen if we poured the milk from this gallon into this little carton? What do you predict would happen? Go. So stand up and go find a partner. So Jeremiah, what do you think would happen? Okay, so find a seat, find a seat. I want to hear some inferences. I want to know what you predict or guess what you think would happen. So, when we make an inference, remember, we're using what we already know, our text evidence, and that's how we're making our inference. Emma, what did you say?
I said that if you put this in the carton, it would overflow because you opened it.
So you think that if you pour the jug of milk into the carton, it will overflow? Dylan, what did you predict?
If you put the milk in the carton, then like flatten down.
Oh, you think it would be too heavy for the carton and it would flatten it? That's a good prediction. Antoine, what did you infer? What did you predict?
If I put the whole gallon of milk in the thing, I'll be like this, then it'll be like.
Oh, so you think it'll go back up?
No, it'll go all over the place.
Oh, so you think it'll make a mess? What do we already know? Do we know that there's more milk in the gallon?
Yes.
Does the book tell us that?
Yeah.
No, we're using our brain, and we know that. And do we know that liquid flows?
Yes.
Right, because that's our text evidence. So we can make a prediction or an inference that if we pour the gallon of milk into the carton, it will flow out. It will overflow.
I know what it is.
Yes. Okay, save your thoughts. 131. Gases. Air, steam, and your breath are gases. Your breath is one example of gas. Gas matter does not hold its own shape. Gases take the shape of their container. The air inside a hot air balloon takes on the shape of the balloon. Gases are easy to compress. So can you stuff them easily or is it hard? So let's read it again. Gases are easy to compress.
They're easy.
Right. So it doesn't take much. Carbon dioxide is a gas. It's inside soda cans. It's squeezed into cans to give soda bubbles. Carbon dioxide rushes out of soda cans when you open them. So raise your hand if you've ever opened a can of soda and you hear the sound. Everyone. That's the carbon dioxide coming out. Why do you think that happens? Why do you think that carbon dioxide rushes out? So I want you to turn to your table partner and tell them. Why do you think that happens? But you have to shake it. Sometimes you get it Why does the carbon dioxide rush out of the soda can when you open it? Why does it go right when you open it? Dylan, what what do you predict? What do you infer?
Yeah, you shaking too much, the oxygen will like make bubbles and pop out when you punch it in.
Okay, you think because it's been shaken too much? What do you think, Kennedy?